Hey there, scientists. Welcome to Room 9, our region's largest classroom. I'm so glad you're here with me today. My name is Mrs. Newby, and I teach at Flint Park Elementary School, which is in the school district of University City. Today, I'm going to be teaching first grade science, but all learners are welcome to join us today, and I'm so excited you are here. So today, we're actually going to learn a little bit about our sun. It is an amazing thing that we have, and it gives us so many awesome resources. We're going to try to notice what do we see in the sky as far as the sun, and by the end of this lesson, you're going to be able to explain why sunlight and shadows change throughout the day. So what I want you to do really quickly right now is look out the window or step outside your house or wherever you are and see what you notice about the day sky right now. So I have a window right here, and I want to see what I notice about the sky. Well, I noticed that it's blue right now and there's some clouds. Maybe, do you see some clouds where you're at? And another thing I'm noticing is that I do kind of see the sun. It's really bright. Don't you notice how bright it is outside? It's such a beautiful day today. And I see the sun shining, and it just warms my heart and it warms my body. So what else do you notice about it? Maybe some of you guys are seeing birds fly across the sky. You're seeing some pretty clouds that maybe look like funny shapes. But the most important thing I'm noticing about my day sky right now is the sun, and it's giving us that light that we see right now. So we're going to read a book, and we're going to try to see if we can come up with some new facts and some new learning about what is going on during the sky in the daytime. Let's get started. Okay, so the more I was thinking about our amazing sun and all the things it does for us, I also started to wonder, well, why isn't it out all of the time? Why do we have daytime and nighttime? And it seems like sometimes it moves across the sky. I noticed one day, whenever I was leaving my house to go to school, the sun was all the way on this side. But then when I came home from school, the sun was all the way on this side. It's like it's just moving around the sky. I thought that was so interesting. So I want to try to study this question and see if we can find the answer to it. I said, why does the sun seem to move across the sky? Is it really moving across the sky, or is something else happening? So I have this awesome book here called Earth and the Sun by Crabtree Publishing. The author of this is Bobbie Kalman, who is an amazing author that gives us a lot of cool answers about science and just the world around us. So I'm not going to read all of this, but I do want to look at the table of contents so we can see if we can try to answer this question, and maybe we can try to explore it a little bit more. Okay, so if I open this book up, a lot of nonfiction books will have a table of contents. So I kind of skimmed through the table of contents because I only want to read the pages that will give me the answers I'm looking for. So the first chapter is called Earth and the Sun. I think that's kind of an important page to study. So let's take a look at what that page has to say. Earth and the Sun. The sun shines light onto the earth. Without the sun's light, Earth would be very dark. The sun also heats Earth. Earth would be cold and frozen without the sun's heat. Without the sun's light and heat, there would be no life on Earth. That is so interesting, and it's so true. It gives us really important resources, and it also allows plants to survive and grow because plants also rely on the sun for food. So the sun is a really important thing that we have as humans and the earth has to be able to survive. Gifts from the sun. We love sunny days. Give me a thumbs up if you love a sunny day. That is my favorite season, is summertime, because I love when the sun is shining bright. The sun warms us and makes us feel good. Does it make you feel good? Yeah. We love to see the beautiful colors of flowers. That's my favorite. We love to swim on hot summer days. Yep. We love the food we eat also. Do you know Did you know that the sun gives us all these gifts? So many amazing things the sun gives us. So I want you to pause right now, look up at the sky and say, thank you, sun. It's such an amazing gift that we have. So much to be grateful for. Right here it says, the sun gives us foods we eat. It also gives us colors. So the reason why we see colors and we have colors is because of the sun. Awesome. Okay, so like I said, we're not going to read this whole entire book because it gives us a lot of information. So we're going to kind of read it bit by bit. So if I go back to my table of contents, like I said, I kind of skimmed through it a little bit. And when I went further down, I saw something really interesting. Right here it says, what are shadows? And it got me thinking, why are shadows part of a sun and earth book, right? But then I started to think a little bit more, and I realized that in order for us to have shadows, you see my shadow right here on the chart paper, we need light. So I thought, maybe that might answer my questions. Let's see what this chapter has to say. Okay. What are shadows? On a bright sunny day, you can see many shadows. Shadows are dark areas. They are made by blocking light. Shadows have the same shapes as the things that block the light. This girl is blocking sunlight from reaching the ground. Her body makes a shadow. The shadow is almost the same shape as the shape of the girl's body. That is interesting. Notice the girl is standing, and it seems like her shadow is really long. I wonder why her shadow looks a lot longer and taller than the girl. But then I'm noticing on this other page, these shadows aren't as long as the girl's shadow. Let's read to find out what they have to say. Changing shadows. What? Have you ever noticed your shadow changing? Maybe one day you go outside and it's super tall like this girl's shadow. And then like maybe another day or a different time, you notice your shadow super itty bitty and you can barely see it. Or maybe it's in a different spot. I wonder if that has anything to do with the sun. What do you think? As Earth turns slowly each day. What? The Earth turns slowly? Wow. As the Earth turns slowly each day, the sun appears in different places in the sky. What? That pretty much answered our question. Oh my gosh, I'm getting so excited. Let's keep reading so that we can maybe jot down some things in our chart paper. Let's read that again because I thought that was so interesting. As Earth turns slowly each day, the sun appears in different places in the sky. So it's not the sun that's moving, it's the Earth? We're actually moving right now? At noon, which is kind of around lunchtime, that's when I love to eat lunch, the sun is right over our head. It's like at the very tippity top of the sky. In the morning and afternoon, the sun seems to be lower in the sky. At the sun's position, as the sun's position changes, the shadow that it makes also changes. Oh, so that's why this boy's shadow is really little. It's probably because the sun was in a different spot in the sky from when this picture of this little girl was taken. And again, it's not the sun that's moving, it's us. We're actually spinning right now. Do you feel dizzy? Let's read this one about this cool bike picture. When the sun is lower in the sky, the shadows are much longer. The shadow of this boy and his bicycle is bigger than the boy and the bike. That is interesting. That is very interesting. So I'm noticing and I'm thinking that even looking at this picture of this girl and how tall her shadow is, that was probably during a time where the sun was really low in the sky. And then I'm thinking, well, since this boy here, who's kind of having a lot of fun in the pool, in the water, he probably took this picture when the sun was very high up in the sky around noontime, because noontime is where the sun is like super, super at the very tippity top of the sky. So when the sun is like super high, maybe that's when the shadow is super little. But then this bike here, this shadow looks really, really tall and long. So maybe this was also taking at a time where the sun was really low, like either in the morning or the afternoon before the sun was about to set. Wow, this page gave us so much information. So I have my cool orange marker because it kind of reminds me of the sun. And I want to jot down some notes here. So what we know so far is that because the sun seems to move across the sky, it's not because the sun is moving, the earth is moving. Let's write that down really quick. The earth is spinning. And you know what else I discovered? A cool science word for spinning when we're talking about the earth is rotate. Can you say rotate? I'm gonna write that down because it's a super, super important science language word, and we wanna try to make sure to remember it. So I'm gonna draw an arrow here, and I'm gonna say rotate. Okay, so we know that the reason why the sun seems to be moving across the sky is because we are moving, and as we move and the sun stays in its place, we see different parts of the sun, or it looks like it's kind of maybe moving across our sky. So I actually did a really cool experiment, and I actually want to go out and check it out to see if anything changed. What I did was I took a really, really awesome lion friend that I have, a stuffed animal lion friend, since we're the Flint Park Lions. Go Flint Park Lions! I set him down on the ground, and I noticed he had a shadow. Do you guys want to see this picture? So here it is, really quick. I want to show you the picture, and then we're going to go out to see if anything changed. Okay, so here's the picture that I took. I put it on this board so that we can actually see it. My friend, Mr. Lion here, is just relaxing in the sun outside. He's still out there. I did not move him. And what I did was I actually traced his shadow. So if you notice here, I used chalk, and I traced around his shadow to see if anything would happen with his shadow. Since the book was kind of teaching us that the reason why we have different shaped shadows is because we are rotating, and then the sun kind of seems to be moving across the sky. So my thinking is, if we're rotating and sometimes our shadow's really long and sometimes our shadow's really short, maybe Mr. Lion's shadow will change after a few minutes. Now, I think I pretty much put him out there maybe about an hour ago. So let's see what happens even just after 1 hour of hanging out in the sun. What happens to our shadow? Let's take a look. Oh my goodness. Only 1 hour passed by, and I can already tell that Mr. Lion's shadow isn't even in the chalk outline that I made. Look here. You can see that the chalk is still on the ground in the same spot that I put it, but his shadow isn't fitting in it. Oh my goodness, so that already tells us that we are spinning right now, and the sun is probably moving very slowly across the sky because we are rotating around, and our sun seems to be moving across the sky, which makes our shadows also move. Oh my goodness, Mr. Lion's shadow moved out of the outline. I thought that was so amazing. Wow, I feel like Mr. Lion already told me so much about the sun and the earth spinning or rotating. So I actually also wanted to show you in real life kind of as a model, what is going on out in space as we speak right now. So if we have the Earth, which is where we live, and I have a green dot right here, or star, silly me. I have a green star right here to show that we are right here in St. Louis. So there's little sign right here, it says St. Louis. It's kind of cool that they labeled it on here. I put a star so that we can kind of see it a little bit better. So if we know that the Earth is spinning, what's that science word for spinning? Rotate, yes. So if we know that the Earth is rotating like this, and the sun is just staying in place, that's what's giving us that day and night, and that's why it seems like the sun is moving across the sky. So I want you guys to do something with me really quick. We are going to pretend like we are the Earth, okay? So we are going to spin. So think of a clock. You know how a clock kind of goes around like this? Well, the Earth actually spins the opposite direction. So think about a clock. It goes clockwise. We are going to go counterclockwise. So I want you guys to spin counterclockwise. How many times can you spin before getting dizzy? Oh my goodness, I already feel like I'm getting dizzy. What about you? This is what the Earth does all the time. It never rests. It never stops. It never slows down. Oh, whoa, I'm already getting so dizzy. Man, that is crazy to think that right now, that is exactly what the Earth is doing. And it's even cooler that we can't even feel it, right? Can you feel the Earth rotating? I sure can't. Man. Okay, so let's get back to our Earth friend here. So we live right here in St. Louis, okay? If I have my handy dandy sun, now I tried grabbing the sun from the sky, but it was just too big to fit in my classroom. So I just had to use a flashlight. Silly me. So we have the sun and we have the Earth with us. If we know that the sun stays in place, here it is shining, but the Earth is rotating, my flashlight is not going to move. It's going to stay right here. Notice that right now, it is shining on us. It is daytime. But if the Earth, is rotating, it's not daytime anymore because the sun isn't shining on it. But again, it doesn't ever stop. It keeps going and going and going. Now notice how it's slowly starting to get to St. Louis. The sun is slowly, it's in the corner now. And then it's gonna get right on top of it, and then it's gonna start disappearing again. That's why the sun looks like it's moving across the sky, because it looks like it's rising and setting, because the Earth is slowly moving towards the sun, like this, and then it's slowly moving away from the sun. So that's why we get the sunlight moving across the sky. And that's an important reason why our shadows look differently. I have another cool experiment I want to be able to show you, is as to explain why and even when our shadows change and what shapes we can predict or think our shadow will look like during certain times of the day. Let me show you really quick. Hey there again. So I actually have another animal friend. His name is Mr. Bear. Say hi, Mr. Bear. He's so cute, and he is going to help us figure out how in the world and when in the world does our shadow change shapes depending on where the sun is in the sky. So again, I couldn't grab the sun from the sky, so I just have to use a flashlight, but that's okay. So if we know that sometimes the sun is low in the sky, and then other times it's super like on top, like on the very tippity top of the sky, And then other times it's low again. We know the terms sunrise and sunset. And I think that probably is the reason why we have different shapes in our shadows. So if I use my sun, and Mr. Bear right here is going to be our sun blocker. So he's going to be the one that kind of blocks the sunlight to kind of give us his shadow, okay? And I want you to notice what is his shadow shape, okay? So here's the sun's about to rise. Here it goes. Oh, that's interesting. So I'm seeing that the sun is on this side, but Mr. Bear's shadow is on the other side. And what else do you notice about it? It's super long. Because the sun is still getting ready to rise. It's still the earth is still slowly spinning towards the sun. So in the very, very early morning when you see the sun, I want you to pay attention to your shadow. Is it super long like Mr. Bear's is? And then as the day goes by and the earth continues to rotate, the sun is gonna start going all the way to the tippity top. And here it is around noontime. So remember, noontime is like lunchtime. That's when I get super hungry. What do you notice about Mr. Bear's shadow? I can barely see it, can you? I mean, I see like a tiny sliver right here. That's so interesting that the sun is at the very tippity top and it seems like Mr. Bear's shadow disappears. I want you to see and find out if that happens to you. At noontime, right before or right after you eat lunch, go outside and see where your shadow is. Is it super little? Or is it just not there at all? So this is telling me that if the sun is right at the very top of the sky, our shadow is going to be the shortest. And then as the day goes by and the earth continues to rotate, it's going to come on this side. What are you noticing about the shadow? Now it's ending up on this side of Mr. Bear. The sun is on this side because it's setting. Because remember, the earth is rotating in a full circle. It's not going to go, it's going to go in a whole circle. So as the sun starts to be on this side of the sky, Mr. Bear's shadow is on this side, and it's long again. So now I want you, after dinner time or right before dinner time, I want you to go outside, and I want you to see, is your shadow super long? And most especially, I want you to see, is your shadow on the opposite side as it was in the morning time? Man, this is so amazing. So not only do we know that Earth or us spin or rotate to give us day and night, and also to make it look like the sun is moving across the sky, we also know that our shadow, because of the place of where the sun is in the sky, our shadow is going to be on the opposite side of where the sun is shining. It's going to be super long in the morning and the afternoon, and it's going to be super short and little and almost not there during noontime at the very brightest day of the brightest time of the day. Wow, I feel like I learned so much today. Let's go back to our anchor chart so we can add more learning and we can kind of put all of this learning together. Man, today's lesson was so fun and so amazing just to learn a little bit more about our Earth and what's going on in space, because it's not like we can just fly up there and see what's going on. So it's really awesome that we have amazing scientists to find this information for us, and we can also explore it ourselves. So I would like to kind of review everything we learned today so that we can be able to explain it to other people. We have so far our main question today, which was, why does the sun seem to move across the sky? And discovering and learning how to find that answer, we've also discovered so many other pieces of information that kind of go along with it. we learned from the book that the earth is actually the thing and the one that is spinning, and the sun is not spinning at all. It's not moving. It's not going around us. We are actually the ones that are going in a circle to give us that day and night. And what is that really, really important word that we learned for spinning? Rotate. Yes, so the earth is rotating. Kind of like when we were kind of going around in circles and we kind of got dizzy. That is exactly what the earth is doing. It is rotating, and that's why we see the sun on different parts of the sky during different times of the day. And we also were kind of exploring with shadows, because I kind of got super curious about shadows. And we learned that our shadow changes because of where the sun is. Now we know that the sun changes places because we're the ones spinning or rotating. And the reason why we have different shadow shapes and the reasons why our shadows change is because the sun is in different places. So they kind of connect together. Kind of cool. And we learned that in the morning time, our shadow is super long on the opposite side of the sun. In the noon time, at 12 o'clock noon, which is the brightest time of the day, the sun is super high up in the sky and our shadows are barely there. They're super short. And then in the evening time, when the sun is on the other side, our shadow is going to be on the opposite side of the sun, and our shadow is going to be super long. So I have two bear friends right here, and I want to show you where their shadow would be, and I want you to help me out. Where do you think their shadow would be if the sun was shining on this side, or if the sun was shining on this side? So let's take a look at this red bear friend right here. So if the sun is shining right here, it looks like it's about to either rise or set, right? So where do you think the shadow is going to be for Mr. Bear? Is it going to be right here on the same side of the sun? No. Is it going to be like super itty bitty in the middle? No, that's when the sun's way up high on top of Mr. Bear. Oh, it's going to be on the opposite side, and it's going to be pretty long. So I'm just going to kind of, and then color it in. I know it looks like a silly shadow, but we know what it means, right? So we also need to understand that our shadows are always connected to us. So it's always going to be connected to our feet if we're standing up outside. I am so excited for you to be able to explore this. If you guys have chalk at home, or if you guys have some type of thing to outline a shadow, I want you to outline a shadow during one time of the day and then wait a few hours. I know with mine I only waited about 1 hour, but wait like a few hours. Maybe do it in the morning and then like check up on it right before the sun sets and see what happens. You probably notice that the shadow is on the opposite side of where you made the outline. I don't know. Hopefully you guys have so much fun doing this activity and exploring so much about your shadows and knowing why our shadows move and why our shadows are different shapes. Because we are rotating. I had so much fun today. It was awesome being able to learn all of this information about our Earth, and I hope you have so much fun exploring even more. I'll see you next time. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.